Full Ahead, the podcast about ships and shipping, with Nigel Thompson and Alistair Eagles.
It's the Full Ahead podcast. My name is Alistair Eagles.
And I'm Nigel Thompson.
And Nigel, it's been a busy few weeks, but that last episode, wow, the reactions have been really good, haven't they? It's been listened to loads of times, that one, the Stena connector.
I hadn't realised and hadn't visualised perhaps the speed at which the rotor sails go around. We saw that video. We were very kindly allowed to share some of the video from the company that produced them as well. They were telling us about how it actually works, and it's not till you actually see it that you realise that the speed with which they rotate.
Yeah, and we would see them in port in their kind of non-active mode, just slowly spinning. But when you see these kind of 28 metre high towers, 4 metres wide, spinning at 225 RPM, really is a sight to see, and really kind of, to me, emphasised what they're doing, why that effect takes place. And yeah, thanks to Norse Power Rotor Sails for telling us all about it. Thanks to Stena Line for allowing us on the Stena connector to have a look around, and obviously the captain for his hospitality.
It's a good looking ship, and it's a very distinctive ship. We've seen a number of people who've kind of shared pictures as it's made its way between Belfast and Heysham. A friend of mine in the Isle of Man, for example, took a picture of the Point of Ayr, the far northern tip of the island, and he said as it goes past, he says there's no mistaking what that ship is. You can't it looks so different and so special, doesn't it?
Yeah, and a kind of misunderstanding. Most people think the wind spins the towers some way, like a windmill, and that creates power that powers the ship, and it's actually completely the opposite. Power is used to spin the rotor sails, the Norse Power rotor sails, and that's what creates this effect, the low pressure, the high pressure, and the forward momentum. So yeah, I hope we've helped people to understand what's going on with the Stena connector and the Norse Power rotor sails that are on there. And it's interesting as well, Norse Power as a company, kind of quite well developed in their journey to fuel saving. They've been around for a number of years. This is on a wide number of different variety of ships now, and they're kind of moving into the phase where how do we produce this en masse at a decent price and start installing it on more and more ships. They're at a very kind of, I would say, settled stage of their development. And this week we're going to speak to someone at maybe the other end of development, but also doing something very similar in trying to reduce fuel burn and increase efficiency.
This is Full Ahead.
Extremely good timing, isn't it, as we're talking? And who would have thought last time we spoke that there'd be a full-scale war in the Gulf, which is effectively what's happening at the moment, and the effect it's had on fuel supplies, the price of fuel. So I think anything that's related to making fuel go further or reducing the reliance on conventional fuels is obviously the topic of the moment, isn't it? Yeah,
of course. And as fuel prices spike, that element of your costs in a shipping company just becomes a bigger and bigger percentage. So these fuel-saving methods, when we talk about 7 or 8 or 9 or 10%, to the outside eye, it might sound like not very much, but when you consider the fuel bills that some of these ships have, a 10% saving is absolutely enormous. And it's not just about the environmental benefits, of course. If you're saving that amount of fuel, you're also reducing your costs. And in the shipping world that's highly competitive, reducing your costs is, also pretty important.
And also, I think I was reading as well that the benefit it has on the environment, apparently using this system, which we'll talk to our guest in a minute, the side effect, if you like, is that it makes the ship's process or progress quieter.
Yeah, all sorts of interesting things to discuss with Armada Technologies. So last time we were speaking about wind power and rotor sails and how wind power can help to reduce fuel costs and fuel burn. This time, bubbles. We're going to be talking about bubbles and what putting bubbles under your ship can do. And with that, let's get ahead and talk with Armada.
My name's Alex Routledge. I'm the Chief Executive of Armada Technologies. So I'm a naval architect, studied up at Newcastle University, spent about 10 years at Shell, and then I founded Armada Technologies in 2021.
Thanks very much for joining the Full Ahead podcast, Alex. It's great to have you along. And air lubrication. Armada Technologies specialise in air lubrication for vessels. To the uninitiated, can you just briefly describe what air lubrication for ships is and what it does?
Yeah, so air lubrication is a concept of injecting air into the boundary layer of a merchant vessel usually. So generally the concept is you put the air into the boundary layer to reduce the frictional resistance. That, if you're reducing frictional resistance, reduces the power to meet speed, and therefore less power, less fuel, less emissions.
So boundary layer, just again, as Alistair pointed out, the uninitiated, that's me. So does that mean kind of underneath the actual hull itself?
Yeah, so the wetted surface area of the ship, as it moves through the ocean, there is let's say a wrap of water that sits and has a very specific hydromechanical property. So if you imagine a ship moving through the water water molecules in immediate contact with the hull plating, they almost stick to the ship. So it's almost what they call a zero slip condition. So that's static relative to the ship. Then you have what they call a log layer, which is a velocity gradient between that static condition and the free ocean. Within the boundary layer, you can have different flow mechanisms, so laminar flow, transient flow, and turbulent flow. But essentially the objective with air lubrication is to inject air as close to the hull as possible to displace seawater and reduce that skin friction.
And these kind of systems have been around for a little while, as I understand it, but you're doing something a little bit different at Armada in terms of how the bubbles are created, I understand.
That's absolutely right. So air lubrication in some form or another has been around, depending on who you ask, and particularly what country, whether it's Russian or American, will tell you a different sort of origin story. But essentially air lubrication has been around for tens, if not hundreds of years. It started life as a noise abatement technology, I think mainly for military application. And then prior to 2000, you started seeing these things turning more from a noise abatement technology into let's position the outlets, whatever nomenclature that you use, to the forward part of the ship, because that air is actually producing energy efficiency benefits. So the concept has been there for quite a number of years. Where Armada is different is, let's say, what we term first generation air lubrication systems, which by definition are ones that require air compressors, so high pressure, high volume delivery. Armada's quite fundamentally different is that we don't use compressors. We have inlets. As the ship moves forward, those inlets are designed to drive water into the system, and what we have is an ejector. So an ejector is something that's very commonplace on a ship. Sewerage plant in the galley, it's all over ships. It's something that the guys on board the ship are very familiar with, but it works on the Bernoulli's principle, which essentially is if you push water through a nozzle, it speeds it up. And then according to Bernoulli's, if you speed that flow up, it's met with a drop in pressure. We use that drop in pressure to create a suction. So instead of mechanically forcing air down against the hydrostatic pressure at the bottom of the ship, we use that hydromechanical process through an ejector to suck air into the system. So that's how our systems actually, the mechanism is fundamentally different.
So the fundamental difference compared to existing systems is a bit like we saw with the Norse power rotor sails. They required energy in quite large amounts to spin the rotor sails, but that hopefully gives you a saving back. And existing air lubrication needed quite a lot of power to run the compressors to create the bubbles, whereas your system effectively passively creates the bubbles with a lot less energy requirement, meaning more of the savings kind of pass through in real terms as opposed to being eaten up by the cost of running the compressor kind of thing.
That's absolutely correct, yeah. And that is the PALS, passive air lubrication system, is the sort of trade name for the system.
And in terms of being effective, I was thinking about the other day about sort of seeing ships in dry docks and watching them being repainted. And I know there's different types of paint that will help ships apparently slip through the water more easily. So does it, in what terms of benefit does it bring? And also I wonder about the size of the ship. The video that we'll share on our social media channels, which you kindly share with us, that was a massive, was it LPG tank? It was huge. But the idea of trying to make a benefit to a vessel of that kind of size, to my mind, just thought, well, that would have to have some, would have to go some, frankly, to make such a benefit. But can it work?
The ship that was in the video was our first installation. So we decided to go quite big from the get-go. So that is a nearly 300 meter long, 160,000 cubic meter LNG carrier. Wow. Owned by CoolCo, more recently acquired by Eastern Pacific Shipping. So that was that vessel. So we had a fantastic pilot system and test bed for us to test our system upon. In terms of the efficacy of the system, almost as you allude to, sort of painting system, advanced coating systems for hydrodynamic efficiency of the hull form. I mean, if you think about a ship sailing through the water, forget wave making resistance and form drag and things. If you just think purely about frictional resistance, which is what air lubrication systems target, you've really got three components. You've got the medium by which the ship is sailing through, mainly seawater. You've got the wetted surface area that the ship sits in. So different ships have different wetted surface areas. And then you have the surface texture of the hull. So this is why coatings are so important, is because obviously if you don't have coatings, then you get growth, and then the surface texture is not as hydrodynamically favorable. But the thing with air lubrication is if you can you're changing the media which you're sailing through with the addition of air. So air lubrication tackles that. If you can maximize the wetted surface area that you tackle, then that improves the frictional resistance component. And also, if you have an advanced coating system, then it improves the surface texture. And the thing that we look at in Armada is obviously the addition of air addresses the media that you sail through. But if you can tackle sidewall lubrication as well as flatter bottom lubrication, you're also potentially doubling the wetted surface area that you can tackle. And there's a lot of research between ALS manufacturers and coating system providers to say, how do you basically maximize so that the benefits of each are compounding rather than, they work in isolation.
I mean, you only have to look at a glass of sparkling water to see that bubbles go only in one direction, and that's upwards. How are the bubbles formed under the... Why don't they just all disappear up the side? And, how do you make sure the effect is there along a 300-meter long vessel?
Just to challenge that point, not all bubbles will always go up. It's a function of the size of the bubble. So you have bubbles in fisheries and aquaculture, nanoscale bubbles, which are actually oxidizing agents that are used to clean the system. And they're actually neutrally buoyant. They will stay in the water column for weeks and months if they're not agitated to move. From what you're saying, the size of the bubble, we somewhat design the bubble size, because the bubble size does actually have quite an important factor. So if the bubbles are the wrong size, they can act to break apart, coalesce into bigger sort of slugs of air, and even the bubbles themselves can act as foils and be sucked out of the boundary layer if you don't get the right, let's say, semi-homogenized bubble size. That said, if you think about it, you've got a huge ship, particularly one without a lot of curvature and fairing at the bottom. It can't go up because it's got the ship that sits above it. The riser floor of most commercial ships, which ALS is the most effective on, generally are almost flat bottomed. But it's true. If you're in a seaway and you're rolling, there is a propensity of the air carpet to move over to the turns of bilges, and you can lose air sheet off the side of the ship. And again, one of the differentiators for Armada that we've worked quite a lot on is because each one of our units is an individual operating entity, you can tune the output. So you can actually do pure water lubrication at the outermost units and over lubricate the centerline units and use that riser floor and the roll motion of the ship to more evenly distribute the air carpet, instead of just sort of non-discriminately throwing air to every outlet and losing the air sheet in the seaway.
So you can adapt for different drafts, different lengths, different bottom shapes, if you like, a flat bottom as opposed to a V bottom or whatever. You can tailor the system to the type of ship. What about bad weather? I mean, just by the nature of bad weather, I'm presuming your system works better in calm, flat conditions than it does in rough conditions, or is that not the case?
I think so. That's the case for any, let's say, anything trying to tackle frictional resistance. As the ship goes, the same ship goes into different sea states, the components of resistance change. So you might have a different wave making resistance or form drag versus skin friction, depending on what sea state that you're in. But essentially, air lubrication is most effective in calm conditions, mainly because the component of friction resistance is the largest in that condition.
And Alex, I've got the probably $1 million, $1 billion question. The first ship then, how is it doing? What difference has it made?
Yeah, so we installed right at the back end of 2024. I mean, what I will caveat is to say that we're in a market now, we're in a technology category where there has been, large claims of performance. So there's big claims, 5 to 10% and higher. And then there's the reality of what these systems actually deliver across a real operating spectrum. So that isn't selective, at 17 and a half knots in light ballast conditions, this is what you get. This is actually what is the impact on the bunker bill to the owner. And what we're seeing, talking to many, many owners, is there is a decoupling between expectation and reality. And this is something that Armada's being very careful to be not hasty, not go out with numbers straight away. It's to go through an absolutely robust, independent data analysis procedure. So we work with two completely independent data analysts who work for Armada, and as well as DNV. There's two independent analysts work off the DNV 0695 procedure, which I'd say is the most well-regarded procedure from within a pool of ALS manufacturers, and then we implement that. So at the moment, we've not gone out with a performance claim. That's very purposeful. We will be doing it within the course of this year, but in order for us to do that, we need a substantial enough testing within each speed and each draft category. So we don't go out with a single figure. We'll go out with a figure that says at ballast conditions below 10 knots, this is what we got on that ship. Laden conditions above 10 knots, this is what we got on that ship. I think it's important to say what you get on an LNG carrier is interesting to owners of cruise ships and container ships, but you have to really get into the discussion of what that number means to that ship, because ultimately it's the OEMs, it's the makers that are going to have to back up their claims with actual, whatever you want to call it, liquidated damages if you don't hit that performance, which is right. If you're going to give out a claim of a performance, you should be able to be sitting in that with the owner and taking that technical risk alongside them. And
talking of cruise ships, I know you've had some exciting news in the cruise ship industry recently. We'll come back to that. But just looking at where you are as a company, I mean, you're a relatively small company. You've been around, I think, for 4 years or so. You've taken a very kind of measured, steady approach to developing the system, done proper testing in tanks out in Holland. And, how difficult has it been to take an idea from a naval architect to, getting it onto an LNG carrier? How is that process?
Well, it's been a tremendous learning curve. So I am a technical person. So I co-founded with Alistair, someone I think you know quite well, Roger Armson. Me and Roger have pretty different skill sets, but collaborating together, we were able to get the business off the ground and moving. We then brought Johan van der Merwe is our CFO in, who really brought the expertise in fundraising. And, they always talk about lots of people have ideas, but it's the execution of that idea, which really is the challenging thing. And to get it off the ground and working, you really need the technical with the operations, with the finance, and those things to be working in sort of a harmonious sort of cycle. So it is difficult. I'd say the hardest thing for a company at our stage is going through funding rounds, going out, finding the financing, building the vision, selling the systems, finding the letters of intent from owners to understand what the performance markers need to be to unlock not just one, but a fleet order and these sorts of things. So I'd say for me, it's been a fantastic learning curve. It's been very challenging at times, but it's something I'm very passionate about. I'd also credit a gentleman called Richard Tyrrell, who is the CEO of CoolCo, who gave us that opportunity to deploy it on his ship. I'd say without his involvement, you needed to find that senior technical evangelist, and he is at the CEO level, who could make that decision and believed what we believed, and absolute credit to Richard for having that belief. So that was the one thing. The other thing I'd say is generally that we've seen with most energy efficiency technology concepts is people don't like putting novel technologies on their brand spanking new ship. They like to see that the system is de-risked on a ship that's 10, 15 years old, get the data, and if you can prove the data, then we'll deploy it. So We are working with a number of shipyards on new build applications. The economics of the projects make a lot more sense for new build because you build it in at the block stage. You're not taking perfectly good material out to install other material that you've paid for. There's no implication on dry dock duration. That's the other thing. Not so much for our system, which we installed in under 7 days, which was remarkably quick. For other systems, if you become the critical path item on a dry dock, then every day that you're off charter, every day that you're in the yard and hiring that dry dock really is part of the cost of that project. And then you'll start nullifying the actual economics of the project. So yeah, new builds are a really nice application. And without looking at the numbers, I'd have to remind myself, I think from memory, by far the majority of ALS installations are at new build now. Now the technology is known as a credible technology category.
The people and their stories. This is Full Ahead.
Going back to that funding model, the funding you found, has that been from government funding on some of their kind of innovation type schemes, or has that been private equity funding, or how have you got the funding to get to where you are today?
Yeah, it's both. So we've been fortunate with grant funds, Innovate UK funds, Fast Start, Liverpool City Region grants, transport technology, they call them TRIG, I'll have to remind myself, we've had a few of those. We also were awarded with a EU Horizon, which is part of a much larger consortia that's just coming to an end now. So we've been successful with that, but I'd say in large part it's been through sort of the private market, either from strategic investors such as CoolCo EPS, Armada Tech Group, let's say, are more strategic investors, but then to financial institutions such as Future Planet Capital, Founders Factory, Oracle, BC. So we've brought in investors in multiple different ways, and it's good. I think we found it's been quite successful having a spread of strategic and financial investors, because the motivations are somewhat different, but they sort of talk to each other with their own motivation. You end up sort of the best of all worlds.
And the next step of your development, you've recently signed an agreement with TUI for the cruise ships to install a couple of systems on their ships. Is that your real kind of proper first commercial order then?
Yeah, that would be the first truly commercial project that we've done. So that is an 8-pod installation on Mein Schiff 6 that will be done Q1 of next year. As with a lot of these things, the sort of if you can go out and demonstrate performance, then it proves the business case across sister vessels, and that's usually the way that Armada likes to work. Is we'll do this land and expand type approach where you go and find a pilot. Going back to the same thing I said earlier, if you take LNG data to a cruise company, you've still not completely de-risked the technology. They need to know that it works on something with a block coefficient and a hull shape and a speed and a draft profile that looks like that. So there is always a technical risk on a new shipping category. So we go and we find let's say an evangelist who likes what it is that we're doing, who can see the differentiation and will give us the opportunity to do that. You prove it with them, and then you use that as the data bedrock to go and find others within the category. So that's generally how we're doing it. And
I guess been involved with the university. We were talking to Professor Blanco Davis, who we spoke to earlier on the podcast a few episodes ago. What's it? How important is it to have that link with an institution like Liverpool John Moores University?
Yeah, very much so. I mean, we worked a lot early days with Newcastle. I was an alum from Newcastle. We did some testing in the Emerson cavitation tunnel. More recently with Liverpool John Moores. Liverpool John Moores have a sort of a centre for maritime innovation. Obviously, we're a Liverpool-based company, and the specialisms that those guys have in that particular department, in terms of particularly sophisticated multi-phase CFD assessments, and the experience that they have in bubble drag reduction technologies, it was pretty well. I mean, it was brilliant that they were Liverpoolian and had that expertise. So we had the guys from Liverpool John Moores support us on our proof of concept test at HSBA, and also just as part of multiple grant projects. So we have a really good relation. We do enjoy working with Liverpool John Moores and hope we can continue to do so into the future.
Are there any negative effects of your bubbles, however big or small they are? But, you think of bubbles maybe and cavitation around propellers and potentially causing damage to propellers. Does putting bubbles under a ship deliberately have any negative impacts on paint wear or, cavitation around propellers, or is it all good?
Theoretically, there is the propensity of air lubrication bubbles to create cavitation is almost what Wartzilla put in their thing as a myth. So the difference between a cavitation bubble and an air lubrication bubble is a cavitation bubble is a vapor bubble which is created again out of Bernoulli's principle. Is you have such high speed that it drops the pressure so much that you pull the vapor out of the water. Crikey. And it's a sort of a temporal event. So once that bubble moves out of that super low pressure domain into a higher pressure domain, it implodes, and that creates the pitting action that it causes cavitation. What air lubrication systems produce are structurally sound bubbles. So they're not vapor bubbles, they're air bubbles. And for that reason, they don't have that same propensity to produce cavitation. So cavitation, I think, through acoustic emission tests, through cavitation borescope observations, has been disproved from other systems who've deployed air lubrication. In terms of other potential, let's say, negative impacts, which usually we get asked by owners, is one of which, if you've fitted fins or propeller boss cap fins or newest ducts and these sorts of things, is there a risk that if you aerate the flow that it reduces the efficacy of those systems? We did a podcast with Becca. We worked closely with Armada Tech Group, who have their Flex series, which is a similar thing. So working with both, there's no reason for that to have an effect. There's no technical rationale as to why that would create a reduction in the efficacy, even if you do get that amount of air that far down the ship. The other effect, again, theoretically, is if you are injecting air underneath the ship, does that create a more favorable site for fouling? And there were two trains of thoughts with that. Are the additional shear stresses created by that air carpet going to detach fouling more easily? Or is it creating a harmonious environment for fouling? So we've not installed the system and subsequently brought it back into dry dock to inspect. So I transparently, I don't know on Husky, although nothing would suggest that we are getting increased fouling. But I do believe from other ALS systems that they have brought ships back into dry dock and they've found that there's no additional fouling. Of course, on big ships so far down in such dark areas, it's not an ideal place for fouling, and the quality of the coatings these days are so effective that it's not really seen as an issue.
It's fascinating stuff, and without getting too deep into bubbles and whatever, but your bubbles, passively created PAL's Armada bubbles, are they better bubbles than ones that are created by compressors? Is your system beneficial in terms of over a wider range of speeds or different weather conditions? What makes your bubbles special, Alex?
I think that the bubbles themselves are obviously just.
How big are they? How big is an Armada bubble? Give us an idea.
Well, so we went to HSVA and we did testing, and actually the size of the bubbles is sort of quite proprietary, if I'm honest. So I can't.
Sounds like a secret, right? Okay.
So obviously companies like ours, you have sort of secret sauce stuff, you have know-how, and then you have the IP stuff. The size of the bubbles is dictated by what we call the diffuser. So the diffuser size will dictate the size of the bubbles. So we design the size of the bubbles within our system. Not every bubble is going to be 100% micron but we semi-homogenize to a certain size. And that's to prevent breakup, to prevent coalescence, and to prevent sort of that idea of a foil effect sucking the bubbles out of the boundary layer, maintaining them close to the hull boundary. So the bubble itself, obviously, a bubble I think it's the most efficient shape in nature. So it is just a cylindrical bubble. It's all about the size of it and how you deploy it into the boundary layer, which is critical. So when you say how is an Armada bubble different to another air lubrication system bubble, the compression makes no difference. It's not like there's any difference in the characteristics of bubbles in that way. But I guess that one of the main things for us is how you deploy them. So putting them into the boundary layer, and particularly what you call the viscous sublayer of the boundary layer, and really getting a richer aeration concentration there is important. But also, as you say, if you're rolling in a seaway, how do you make sure that you maximize the retention of the air carpet on the flatter bottom and you don't get this loss of air sheet? And that really comes down to tuning the output of each pod. So as I said earlier, if you imagine that ship is rolling and the buoyancy effect, once it's given an opportunity, it slides off the side. If you imagine now that you can blanket with with water, and then you over lubricate the centerline ones, you can imagine as long you can retain it. Whilst the air carpet might snake along the bottom, it's still retained on the flatter bottom. So it really, I'd say the difference between our bubbles and anyone else's bubbles is the way in which you deploy them into the boundary layer and retain them in the boundary layer to the back of the ship.
This is Full Ahead.
I think a future edition we need to look at in more detail about fluid mechanics and things like that. Obviously, it's a big thing in terms of efficiency and certainly your area of work. But yeah, Alistair was mentioned about the Earthshot and about your connections and your links to that. Can you just tell us a bit more about how you are connected and what you hope to achieve?
Yeah, so the Earthshot Prize is obviously a very, very prestigious award that is granted to companies working within the environmental space. And obviously that's from a whole array of different, predominantly hard to abate industries, of which maritime is one of them. We were very happy to be nominated towards as a contender towards that award. And at the moment, I believe the reviews are underway as to see if Armada will be successful with that. So, I mean, if nothing else, just the recognition is super exciting for me personally, but also a company like ours. So it's one of our investors, Future Planet Capital, that put us forward as a nomination. So we're very, very grateful for that.
And for me, it seems really kind of topical at the moment. I mean, first of all, shipping emissions, when you read reports about worldwide emissions and what shipping contributes quite a significant amount to worldwide emissions. So that's kind of in focus already. But then put on top of that current fuel costs with what's happening in Iran, the pressure on fuel, surely this is going to push more and more owners to look at technology like this. Yes, from the environmental ground, but also if you save fuel, you save cost, and in a really competitive shipping world, that's important too, I guess.
Yeah, 100%. And sure, Alistair, you probably had the knock on the door from people such as myself and Roger and Johan a number of times during your career. But so I think you're absolutely right. Obviously, there's a very core principle to, if you're going to invest in this technology, it needs to pay for itself in a short enough period to be attractive. And usually those payback periods are linked usually to charter durations, so time charter periods. Obviously, an owner's going to pay for a system and the ship's on charter for 5 years. They're not going to invest in something that's got a payback period over 5 years, and probably substantially less than that. But you're right, the components is if you physically have to buy less bunker, then that is an immediate drop to the bottom line that is very attractive to owners. I think the other thing that's really interesting is the ever-evolving picture of environmental compliance and the cost of compliance. So I know it was unfortunate last October the net zero framework didn't go through in the way that we hoped at the IMO level. But if you imagine if it did, and some of these are $380 a ton of carbon, that's a substantial. Forget fuel, the cost of fuel. It's now how's the cost of carbon that we're emitting. It becomes a substantial operating cost. So the payback periods become even more attractive with those sorts of things. And
it will happen in some form. The IMO will get their act together at some point. This is coming. It's just not coming quite as quickly as maybe we thought. But Alex, thank you from the Full Head podcast. It's been a fascinating discussion about your passive air lubrication system. I think we've learned a lot. I'm sure our listeners will learn a lot. Will learn a lot from this. So, it's been a fascinating discussion, and thank you for your time. Best of luck with the Earthshot Prize, and best of luck with the systems you're deploying, and I hope it all goes well for you.
Thank you so much.
So passive air lubrication systems could well be the future when it comes to making ships more efficient. I never knew, first of all, they existed. It was a fascinating discussion there with Alex.
No, it's like air lubrication for hulls has been around for some time, but there's always power input to create the bubbles. This system uses very little power to create the bubbles, and that's its kind of that's its secret sauce. And not quite sure how big those bubbles are. That seems to be the trade secret. But yeah, really interesting to me to see a company at a different stage than Norse Power. Norse Power really developed, and Armada here kind of still 4 years in, but at much earlier stage, just signed the first commercial contract to put it onto TUI cruise ships. And that proof in concept is going onto ships now, and does it really work? And being cautious about what the savings are. All too often in these things, you see big numbers that aren't reflected in reality. And I think Alex and Armada are really keen to put figures out that are achievable and, you know, be realistic, which I think is actually far better for a company who's thinking of installing a system. You really want to know the truth when you're working out your kind of payback periods and, you know, whether it works or not, rather than some kind of ideal claim in ideal conditions and ideal sea conditions and an ideal hull. And, you know, you want to know the truth. And it's nice in a way they're not putting a figure out there until they've got that data that's been independently analysed as well.
And that's their work with the university, which I think is interesting, as Alex mentioned in the conversation, the fact that they do kind of buddy up with organisations like universities to provide training opportunities for students, you know, who could well be the maritime employees of the future.
Yeah, and just how you take a kind of concept from an idea with a couple of guys to then, you know, seeking funding from maybe UK or European funds, and then ultimately getting kind of some private funding from Future Planet Capital. But still, you know, still to take this idea through to seeing it widely deployed on a large number of ships, it's quite a long journey. It's not something that happens overnight. And obviously takes a lot of dedication and belief. You know, we never really heard about Alex's story there, but, you know, starting as he did at Newcastle University, doing a kind of naval architecture degree to what he's doing now. It's amazing to see companies like this trying to make a significant difference to the emissions in the maritime world to save fuel, which, you know, as we discussed, there's never been a more important time to reduce your fuel costs than right now.
So thanks to Alex from Armada for a truly fascinating conversation. And I wasn't joking. I think we need to perhaps do another series or another episode maybe about, you know, the dynamics of how ships actually go through water. I didn't know half of what we've learned from Alex. So truly fascinating insights. So thanks to him, and thanks to you for downloading this edition of the Full Ahead podcast. In the next edition, we're talking to another friend of the podcast, somebody we spoke to back in Sweden at the end of last year, Mike, who's made a career out of taking pictures.
Yeah, you often go down to a dock or port and you'll see someone standing at the end of the quayside with a camera taking pictures, and you see some amazing kind of pictures of ships from all around the world. And, you know, I used to do a bit of that myself, and dreaming at the end of that quayside about whether I could turn these photographs into money. Could I make a career out of this? But Mike, who we're going to speak to, has absolutely made a career out of it, and it's going to be really exciting to hear his story in the next episode.
Can't wait. Looking forward to that. Thanks for joining us. Thanks for downloading this edition of the podcast. We're racking through the subjects, and if you want to suggest perhaps a guest for future editions as well, if you've got a subject we should look at, by all means, please get in touch. You can follow us on social media, on Instagram, LinkedIn and Facebook, or of course get in touch with the podcast direct through Spotify as well. It's always good to hear from you.
Yeah, if bubbles aren't your thing, there's plenty more to discuss in this industry, and we'll be doing that over the coming months. Thanks again for listening.
Thanks.